Okay, this chapter is about the atoms. In this, we are going we are going to see we are going to see the discovery of nucleus. पहले मॉडल जे थॉमसन का एटॉमिक मॉडल जो चल रहा था, in that what was thought कि electrons and protons are embedded in the inside the atom like watermelon or plum pudding model. But later on, Rutherford got the intuition that no, there must be something else. So he was of the opinion that protons must be at center and electrons must be revolving around it. So under his guidance, two scientists named as Marsden and Ziegler, दो साइंटिस्ट जो है, these two scientists they were asked to sit down in the dark room and do the experiment, and for many days uh, they they were just doing the experiment, and finally they got कि अल्फा पार्टिकल्स या अल्फा पार्टिकल उन्होंने प्रोजेक्ट किए, गोल्ड फॉइल था, तो दे गॉट द deviation, much large deviation than 90 degree. Most of the particles were deviating very small angle, less than 1 degree. Okay. But very few, after many days, they could pick up one particle deviating at larger angle than 90 degree. That gave the clue, that proved the way, proved the nuclei model. है ना? उसमें protons are that led the discovery of nucleus in fact. ठीक है, ये केमिस्ट्री में भी आपने पढ़ा है, क्या किया था इन लोगों ने रदरफोर्ड अल्फा पार्टिकल एक्सपेरिमेंट में. ये देखिए यहाँ पे गोल्ड फॉइल है, there's the gold foil and alpha particles from the radioactive source were projected on the gold foil, and यहाँ पे ये जिंक डिटेक्टर है, ये स्क्रीन है जिंक. So what they notice, most of the particles are hitting at very small angle, very few are deviating larger than 1 degree angle. Hardly 0.14% of alpha particles are deviated greater than 1 degree angle, and 1 in 8,000 alpha particles were deviated at larger angle than 90 degree. तो इसका डायग्राम इधर देखो, ये उन्होंने इस डायग्राम को स्कीमेटिक डायग्राम दिया, शोन इट लाइक दिस. ये देखो, in 1911 that this Rutherford experiment was done. It was like this. यहाँ से अल्फा पार्टिकल प्रोजेक्ट किया, ये थिन गोल्ड फॉइल, थिकनेस 6 × 10⁻⁸, very thin, and what they found, most of the alpha particles went undeviated, and this is a zinc sulfide screen that is for detection of the alpha particle. तो different angles पे उन्होंने देखा उसको, ये theta is the angle of scattering. 1 in 8,000 bounce back also more than 90 degree. ठीक है, तो what this proves, उन्होंने फिर इस एक्सपेरिमेंट के बेसिस पर he gave his own model, and let's see what is that, and discovery of nucleus was also possible. है ना, जब bouncing back हो रहा है ऐसा, alpha particle is a heavy particle, it is consisting of 2 protons and 2 neutrons. If protons are isolated in the atom, then they cannot bounce back, they cannot just reflect the heavy particle like alpha. The protons has to be together to 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 deflect the heavy particles more than 90 degree. अगर protons ऐसे अलग अलग हैं embedded in that, they cannot alpha particle को ऐसे भेज नहीं सकते. They have to be together. So when the alpha particle is moving head on, it will bounce back. So that proves the discovery of nucleus bouncing back up alpha particle. So these are the conclusion. These are the suggested model. ठीक है, उससे पहले डिस्कवरी देख लेते हैं क्या क्या डिस्कवर किया इन लोगों ने. What were the results? Can you see? Beam of alpha particle from the radioactive bismuth was directed toward the thin gold foil. Scattered alpha particles were observed by the rotable detector zinc sulfide, consisting of zinc sulfide screen. Only 0.14% of alpha particles scattered by more than 1 degree, quite a few, right? And 1 in 8,000 deflected more than 90 degrees. So these two results suggested that there is positive charges at center and there is a lot of free space. And that these last two results suggested that Rutherford argued that positive charge of atom is concentrated at the center called nucleus. This was the discovery of nucleus. He suggested that electrons revolve around the nucleus as planets do around the sun. Electrons का उसने revolving का concept भी दिया. That was very big thinking, है ना? And that was found to be true also. And size of nucleus is 10 to the power minus 15 के order की है, and atomic size is of 10 to the power minus 10. So about 1,000 to 100,000 times larger. So it means most of the atom is empty space. Because nucleus का जो size is very small. So that means, or atom size is 10,000, even greater than 10,000 times. So there is a lot of free space, almost empty है. 99.9% mass तो 90.999% mass तो nucleus के अंदर है. That is also very small for me. So that's how this latest model came into existence. इसमें कुछ problem थी क्या? This model में, was there any question mark on this model? बोलिए क्या था question mark इसके? Almost it was correct. There is one problem. What was that problem? बोलिए. Are you there?
Yes, sir.
क्या problem थी? ये वाली problem थी, है ना? Revolving of electron was question mark, because when the electron revolves around the nucleus, it will radiate the electromagnetic waves. So इसकी energy loss होगी. Finally, it should fall into the nucleus. है ना? It has fallen into the nucleus after some time. How the revolving electron can be stable? How the atomic model? There was the question mark on the stability of this model. Revolving electrons are accelerated electrons, and accelerated charges should emit the radiation and lose the energy. That was given by Hertz experiment, है ना? या Hertz ने बोला था accelerated charge will emit the radiation, electromagnetic waves they will emit. Accelerated charge जो क्या करते हैं, electromagnetic waves emit करते हैं, and they lose their energy. So that was the drawback in this. So what happened later on? क्या हुआ उसके बाद?
Sir, Neil Bohr proved it.
Yes, Bohr's atomic model. He gave the concept of stationary waves. Certain orbits are possible only in that atom can be stationary, or electron can be revolving in that without losing the energy. But he could not prove ऐसा क्यों है. Who rescued? Who came is then who further proved that stability of that. उसने मॉडल दिया, hypothesis दी, but later on another scientist de Broglie, अभी थोड़ी देर हमने पहले पढ़ा था, de Broglie wavelength, he could prove that concept of the stationary orbits given by नील बोर. उसका जो मॉडल था, बोर्स एटॉमिक मॉडल, उसको प्रूव करके दिखाया डी ब्रॉगली ने. हाउ द certain orbits are stationary orbit that will not be radiating the electromagnetic waves. Therefore, electron can revolve continuously in that. कैसे प्रूव किया उसने? By standing waves, nodes and anti-nodes. पढ़े थे हमने. Standing waves will not emit the what is called that energy will be confined to that between the two nodes. तो वो पॉइंट से उसने प्रूव करके दिखाया. Yes, really they are not going to, those orbits जो होंगी they will be integral multiple of de Broglie wavelength and उसमें पूरे full anti nodes and nodes बन जाएंगे और radiation will not be there, it will not be losing the energy. So we'll see one by one. ठीक है, तो पहले इसको फिनिश करते हैं. इसमें so many more points are there to learn. ठीक है, तो लेट्स सी. एक तो ये ग्राफ दिया उन्होंने, what that graph between the number of scattered particles, number of alpha particles scattered versus angle. Scattering angle बोलती है. थीटा जो था ना, मैंने बताया, जो angle of deviation is called scattering angle. ये तो number of particles and angle के बीच में ग्राफ दिया उसने. That comes to be like this, rectangular hyperbolic. You can see ये देखो, ये आपके 100 particles है, 10 to the power 2. कितने? Only 100 particles are having the angle of scattering more than 90 degree. कितने थे initially? 10 to the power 7. है ना? 10 to the power 7 means very huge number. है ना? It is कितने? 10 million particles में से only 100 particles will have angle of scattering more than 90 degree. It's 10 million. है. Most of them, देखो, most of them are having the very small angle. यहाँ से देखो. So this is the graph you should be knowing in the alpha particle experiment. ठीक है. And alpha particle की trajectory कैसी होगी, path कैसे होगी? देखो, the particle which is going, it is alpha particle away from the nucleus will be moving undeviated, and ये जो पास धीरे धीरे पास में आ रहा, थोड़ा डिविजन, बिकॉज ऑफ न्यूक्लियस में प्लस है, इसका भी प्लस चार्ज है, तो रिपल्सिव फोर्स लगेगा. इफ इट कम्स क्लोजर, द फोर्स इज मोर, इट इज डिविएटिंग इज मोर. फर्दर क्लोजर, फर्दर मोर डिविएशन, मोर एंगल ऑफ स्कैटरिंग. फर्दर क्लोजर, फर्दर मोर एंगल ऑफ स्कैटरिंग. और क्लोजर है, ऑलमोस्ट 90 डिग्री पे जा रहे हैं, और न्यूक्लियस की क्लोजर है, तो मोर देन 90. If it is heading on towards the nucleus, तो bouncing back, वापस चला जाएगा. क्लियर? जितना क्लोज है उतना ज्यादा डिविएशन है, उतना ज्यादा एंगल ऑफ स्कैटरिंग है, थीटा. Could you get this? Then no particle will go like this. क्यों? Because repulsive force, it will go away. It will not be attracted because both are positive. Alpha particle is positive and nucleus is also positive. Electrons are revolving here, but electrons are very light in the weight. They cannot apply much force to the alpha particle, which is moving fast and heavy also, and electron is changing its position also, revolving है ना. they are not, their role of force is negligible. All right. So भी lot of empty space, electron कुछ ऐसे जा रहा होगा ना. So closer it is, more is the deviation, more is the theta, and away है सारा, attraction नहीं है. All right, तो यहाँ पे एंड करना है. तो पाथ के ऊपर क्वेश्चन आते हैं ट्रेजेक्टरी में, यू शुड बी एबल टू आइडेंटिफाई हाउ दे कंफ्यूज यू. ऐसे कंफ्यूज करेंगे. देखो जस्ट इसको देखो, वन क्वेश्चन पूछ के वाइंड अप करते हैं. जैसे ये न्यूक्लियस है, which of the path are is incorrect or incorrect. जैसे A, B, C, D, कौन सा पाथ इनकरेक्ट है?
B
Sir,
and
A and D. A and B.
A तो पॉसिबल ही नहीं है. It will be, A का पाथ ऐसे होना चाहिए ना, रिपल्सिव होना चाहिए ऐसे. तो A इज इनकरेक्ट. और इसमें से भी कोई प्रॉब्लम है क्या? इन B, C, D में समथिंग इज रॉन्ग.
so
तो
B.
C जो है, B जो है, B should be deviating more, है ना. B should be going like this. C दूर है, उसका कम है, ठीक है. D is further close. D is very close. It will be deviating more. B is next, तो उसको ऐसे जाना चाहिए, है ना. तो B is also wrong. B should be deviating more. So like this, they can make you and give you. So you should be able to use your logic. कि जितना close है, इस ये logic लगा सकते हैं. ये जो हमने देखा ना, जितना पास में है उतना ज्यादा, which is going head on will be bouncing back, है ना. ठीक है. Clear or not? Shall I stop it here?
So can you scroll up?
Yeah.
So to the result where you wrote the result.
Results and
Yes, sir, above
these
this.
both the points you can see together.
Yes, sir. Thank you, sir.
Okay. Tomorrow I'm giving you holiday. Saturday है वैसे भी कल. GA class was supposed to be there, but we are not keeping because some of you have the exam also. So tomorrow Christmas holiday is there. Merry Christmas. ठीक है. Monday will resume, and there is when is the paper, last paper किसके